that are very long duration, because I tried that before and I could only upload, I had to break the video up into a lot of smaller parts. So maybe I'll try to figure out how to upload it to YouTube or something. Not so much for the workshop, but just for next semester when I have to do this for every course.
If you're gonna upload it on YouTube, is it gonna be public?
I don't know. I've never done that, but other professors do.
I see.
Arsenio does that for his 444 class, and old Dick Hubner does it for his internship class. There, we heard from the Department of Insurance again about they're really trying to fill that position. And I had 2 of our students applied for it about a month ago. So one of our actuarial students who works in the same area where the opening is, we contacted her today, and she's going to find out why those other 2 students didn't even get interviewed. So what I told her is that we might have 2 or 3 students pass an exam at the end of the summer, so we'll have more candidates to give out information. But anyway, the takeaway is that I'm still getting approached for job openings in Southern California. And that's why if you're just here to enjoy the show, you're missing out on a chance to get a job after you graduate.
I see.
The workshop's only held in the summer. So if you do want an extensive dive into the problems, this is really your only chance. After this, you're not going to come back to FM probably, and then you'll be graduated. And if you haven't taken FM by the time you're starting on your other studies, you're just not going to pass it. I've not seen anyone that does it as a hobby. You have to do it seriously, or you may as well pick a different concentration, is my philosophy. Although it's still an interesting topic to study, but it does have a very specific application. When I was a math major, I didn't like any applied math. I just liked pure math, algebra, number theory. Okay, well, anyway, I wanted to go over those 2 notes. Hopefully you got the email I sent out. There was 2 things I was mentioning before everyone joined the show, that we're starting to get into topics that I didn't cover. So even though you won't be able to do like next week's topic, I think we covered most of next week's, but we're getting into topics that we didn't cover much in class. So you may not be able to do them all before we meet up, but that's okay. So the 2 things that I sent out, one is when I was learning bond pricing, we had about 3 or 4 different formulas we memorized to solve for the price of a bond. And the one I go over in 415 is Frank. So it's the straightforward one where it's just the present value of the coupons as an annuity plus the present value of the redemption amount. And that's what Frank stands for. So if you just do some algebraic shuffling of the variables, you can rewrite Frank. So you just use the standard trick. The A angle n is 1 minus v to the n over I. And in this case, you solve it for v to the n. And so you can replace c times v to the n in the Frank formula, and you get this other nice formula where the price is just equal to the redemption amount plus an annuity for the difference between FR and CI. So sometimes this formula is a lot easier and quicker to use than the Frank formula. And so the more of those little formulas that you know, the quicker you can do them, because remember, it's also a speed contest. So if you only know one way of solving it and you do all of them the Frank way, then frankly, that might take too long. So I didn't, I think I used one of this formula for one of the solutions, but then I figured out a different way to do it. But knowing that there's another good formula to use for the price of a bond is helpful. Okay, and then I used Perry right here to help out on callable bonds. And
Question.
yes.
Can I borrow him? I
You can
think I need to
him?
borrow Perry.
Oh.
I need help, but if he's being so helpful.
Oh yeah, especially if you're taking it in August. Well, I'm sure we can work out something.
Okay, cool, perfect.
Yeah, he seems to know the weirdest topics. I don't know where he gets that.
Probably his secret agent training.
Yeah, it probably is. Just like I don't know where he goes sometimes. He just vanishes. So let me describe what a callable bond is, because we didn't cover that in 415. Most bonds in real life are callable, which means that the issuer of the bond, let's say I bought an IBM bond, and they're paying a 6% coupon. So from IBM's point of view, they borrowed money from me and they're paying 6% interest. And let's say it's a 30-year bond. And let's say 10 years has gone by and interest rates like they have dropped. Let's say now they could probably issue bonds at 2%. So what they would do is call the bond they have with me. Instead of paying 6% coupons, they want to just pay me off and then reissue their debt at a lower interest rate. And that's called a callable bond. So obviously, as an investor, you're going to demand a higher return for a bond that can be called, because it's going to be called when it's most disadvantageous to you. So usually when they call the bond, they have to give you more money than the redemption amount. So let's say the face value of the bond was 1,000, and if they wanted to pay me off early, they might have to pay 1,020. So that's called the call premium. So they can call the bond at different dates. So if it's a 30-year bond, maybe at the end of the 10th year, they could call it for 1,020. And then maybe at the end of the 15th year, or any time between the 10th and the 20th year, they could call it for 1,020. And then any time between the 20th and the 30th year, they could call it for, say, 1,010. So that's called the call schedule, and they have different dates where they could, call the bond and pay me off early. So that's what a callable bond is. And so the question that comes up when you're pricing a callable bond is, let's say an investor wants a certain yield. Say I wanted a yield of at least 4%. What's the most I should pay for the bond, a callable bond, that would guarantee me a yield of 4%? And that's how the questions are usually phrased. It'll say, what's the maximum price to receive a yield of at least I%? And if there wasn't a shortcut, you would have to try every possible combination, and that would take forever. So for most of the bonds you'll get on FM, a callable bond, you can use the shortcuts that I have written up. And to determine the shortcut, the first step is you have to determine whether the bond was issued at a discount or a premium. Remember, a bond is at a discount if its price is smaller than the redemption amount. So if P is smaller than C, it's a discount bond. And if P is greater than C, it's a premium bond. And the shortcut is different between a discount or a premium bond. And remember, the other equivalency is, instead of comparing the price and the redemption, you can compare the coupon rate to the yield. If the coupon rate is greater than the yield, so if R is greater than I, then it's a premium bond. And if R is less than I, it's a discount bond. So whichever method you use to determine whether it's a discount bond or a premium bond, that's the first step. And then you hope it's a discount bond, because if it's a discount bond, you can price it exactly as if it was a non-callable bond. In other words, it doesn't matter if it can be called early, you just use the original maturity date of the bond and just calculate the price. So for a discount bond, a bond issued at a discount, there's no additional work. You would just determine the price of the bond as if it was non-callable. So that's a pretty good shortcut, because that eliminates anything that's a discount bond. Now for a premium bond, and the way I wrote it up in my shortcut is you have to check the earliest date it can be called for a certain call price. So in that note, let's say the bond can be called like I described. It can be called anytime between year 10 and year 20 for 1,020, and then anytime between 20 and 30 for 1,010, or then just at time 30, it would pay off 1,000. So you would have to check, so let N1 be the first call date. So maybe that would be 20 years in my example. And you would use the 1,020. You would use the higher amount for the redemption. And then you just calculate the price as if it was a 20-year bond and it matured for 1,020. And then you look at this, the next time it can be called for a different amount. And in my hypothetical, well, now I'm getting mixed up with the hypothetical. But so let's say the original was 10 years for 1,020 and 20 years for 1,010. So you would then calculate the one that has a 1,010 maturity, and it's a shorter one. And then you calculate as if it was never called. And you look at all of those prices that you determined, and you take the minimum of those. So it's very confusing. The book even points out the phrasing of the question is confusing, because it says, what's the maximum price an investor would pay to get a yield of at least 4%? And the solution is, to get the maximum price, you would take the minimum price of all of those prices that you calculated. Usually there's not more than 2 call prices. So example question 11 was a discount bond, a callable discount bond. So that one you didn't have to do anything extra. And then question number 12 was a callable premium bond, but it only had 1 call price. So you only had to calculate 1 extra calculation. But I've seen questions where it's like the one I described, where it gets called, say, at time 10 for 1,020, and at time 20 for 1,010. So you'd have to calculate 3 prices and take the minimum of those. Okay, so that was a little discussion of how you do callable bonds. And I mean, we worked on that a lot in real life. Some students ask, do you ever use this on the job? And yes, because I said most bonds are callable. So if you had to project all of your future coupon payments, you have to put in some probability that the bond is going to get called. And we used a function where the probability was based on how low interest rates were. And if interest rates only drop 1%, the company is probably not going to take the time to reissue all of their bonds. But if it drops 4%, they probably will. So we used a probability matrix that was how much did the interest rates drop, and that affected the probability that it would get called. So you get to use time value of money and probability, which is why those are the first two exams. Okay, now let's get to the questions. I was going to do number 1 and number 4 together because they go over the same topic. And the topic is you bought a bond and then you're taking the coupons and putting them in a bank account, which is pretty realistic because if you buy a bond and you get a coupon, you're either going to spend it or you're going to save it. So you're going to put it into let's say you're going to save it, you put it into a bank account and it's probably going to earn a different interest rate than the yield on the bond. So it's a realistic question. In question 1, an investor pays $6,000 for a 5-year bond that has coupons of 350, I think. Yes, 350, and then pays $10,000. And so as those, so this is the cash flows of the bond, and this is the cash flows of the bank account. So the deposits of 350, and then the last would be depositing the 10,000 plus the last 350. And in question number 1, it said, what is the bank account credits interest of 7.5%? So what was the yield on the investment? And if you're only putting one deposit in, like if you bought a bond, your total outflow at time 0 is just the price you paid for the bond. So to determine your yield, you would just take the initial deposit. And so if you put in 5,000 and you ended up with 10,000, well, then you could determine, if you know how many years it is, you can determine what your realized yield was. So that's how you do questions 1 and 4. So on question 1, we have to determine what is the balance in the account after 5 years. So it's 350 S angle 5 plus 10,000. So the value of the bank account at the end of 5 years is 12,032. And the investor only put in 6,000, so 6,000 times 1 plus I to the 5th equals to 12,000. And from that, you can solve for I, and that's what the investor realized on the $6,000 investment. So they put in 6,000, and at the end of 5 years, they had 12,000, and that's how you calculate their realized yield. Now, on question number 4, we were trying to calculate what was the interest rate in the investment account. So it was very similar, but in the first one, we were given that it was earning 7.5. This time, we're trying to find out what that interest rate was. So we were given that the coupon rate and the yield for the bond were both 6% semi-annually. So that means it was trading at par. So in this question, you weren't given, I can't remember if you weren't given the price or the face amount, but because R equals I, the price is equal to the face amount. So that is each equal to 1,000. So if the price is the 1,000, just like in the one before where it was 6,000, that is the only cash flow that the investor has, the 1,000. And we're told that old Bill, after 10 years, has made a 7% annual effective return. So again, since you only made the one deposit of 1,000, if we bring that forward at 7% for 10 years, that means the value in his account at the end of 10 years is 1,967. And now it's just like the other one, except now we're solving for the interest rate. So we look at the cash flows from the bond, they were 30. So we have a 20-year, so it's 30 times S angle 20 plus 1,000 equals the 1,970, whatever that number is. And now that we have, we can solve for S angle 20 and then use our financial calculator to solve for I. So in this case, the financial calculator, you put in and you get I is equal to 4.795. But since these were in 6-month periods, that's why N is 20, we have to turn the semi-annual effective rate into an annual effective rate, since the question said, what's the annual effective rate of the savings account? So there's just one last converter box step to turn it into an annual effective rate, and you get 9.746. So questions 1 and 4 were the same concept where you're reinvesting cash flows, and that comes up, that type of question comes up a lot. Okay, any questions on that concept? Great. Okay, we'll do numbers 2 and 3 now. They were kind of similar. Remember all the analogies between bonds and loans. And for a loan, we had what's the principal portion in the TEEF payment and what's the interest portion in the TEEF payment. And we had a lot of formulas. But the one that was used a lot was that the principal portion of the TEEF loan payment was X times V to the N minus T plus 1. And then the interest portion was 1 minus V to the N minus T plus 1. So you have similar things for a bond, but instead of the payment, you have the premium amortization in the TEEF coupon payment is FR minus CI. So there's that FR minus CI again that was in that other formula that we derived, FR minus CI. So that difference comes up a lot, the difference between the coupon and the redemption amount times the yield. So that is a handy formula to have for the premium amortization. Okay, so what do we have in this case? So here's the bond. It has a maturity of 105. The must be semi-annual payments. Yes, so a 12-year bond, it's redeemable for 105, and the yield is 4% compounded semi-annually, so 2%. And we're told that the premium amortization in the first coupon payment is 60 cents. So PA1 is 0.60, and we use this formula, FR minus CI, and V to the N minus T plus 1, N is 24, T is 1. So we have 60 cents is the coupon, FR, minus, well, the redemption amount is 105, and the interest rate is 2%. So, and that simplifies to V to the 24th. So from that, we can solve for the coupon payment. So FR minus the 210. So from that, you can solve for the coupon payment. And so the coupon payment is $3.065. And now we're trying to find the book value immediately after the 8th coupon payment. So now that we know FR, we can use the Frank formula for the book value. The book value at time 8 is FR, well, there's 16 payments left, times CV to the 16th. We just calculated the coupon, and now you just bring back the 105 for 16 years, and you get the book value at time 8. So 118.10, which was answer D. And then remember, because of that V to the N minus T plus 1, that series of, well, for loans, the principal portion, and for bonds, the premium amortization, form a geometric series. And so when you take the ratio of two of those, you can get the interest rate. So you have PT plus K over PT was 1 plus I to the K, and the same thing works for bonds using premium amortization. Now, remember in class when I said the book talks about accumulation of discount and even has a different abbreviation, DA. But the accumulation of discount and premium amortization are just the same. It's just, is it the bond coming down in price from the purchase price to the redemption amount, a premium bond, or is it going up from the price to the redemption amount, a discount bond? But the absolute value of PA is the same as DA. So you just have to remember, for a discount bond, premium amortization will be negative, and for a premium bond, it's positive. So in this case, in question number 3, what do we have? A 10-year bond, it's got 5% coupons, a par value of 1,000, and it yields 10%. Let X be the amount of accumulation of discount in the 3rd year, and let Y be the interest earned in the 8th year. What is the sum of those two? So basically it's asking what is PA3 plus I8. Is that right? Yes. So the first thing, we look at the bond, and it's a discount bond. So if we use that formula PAT, we'll see that we're going to keep getting negative numbers for the premium amortization, because FR minus CI will be negative for a discount bond. But you can pretty much ignore that, because the negatives will always cancel. You just have to be careful when you're subtracting. So let's see, what did I do here? So PA3 is 50, that's FR, minus 100, that's CI. And it's 10 minus 3 plus 1. So you get PA3 is negative 23.325. But since X was accumulation of discount, it's the opposite of that. So it's a positive number. The premium amortization and accumulation of discount are always positive numbers. It's just the way I just always call that premium amortization. If you want to use the book's notation and never have a negative number, just use DA. You just have to remember more formulas. But to me, it's easier just to know, all right, if it's negative, then it's called, the absolute value of that is called the accumulation of discount. So X, which is the absolute value of PA3 is the 23 number. And now we need to find Y, which is the interest portion of the 8th. So to do that, there was a couple of ways to do it. We didn't know the, let's see, what method did I use here? I tried to get the premium, or I labeled it as P, it should be PA. The premium amortization in the 8th coupon payment. So I used this formula that PAT plus K over PAT is 1 plus I to the K. And since we know the premium amortization in the 3rd, we can get the premium amortization in the 8th payment. And then the interest portion of the 8th payment is just the coupon minus the premium amortization in the 8th payment. So I use that method to get I sub 8, which is what Y is, and then I added X plus Y. And then I put note, you could also use the formula, the interest portion of the 8th, and the interest earned in the 8th coupon payment, you could use the book value at times 7 and multiply that by I. So I was just showing that there's several ways you can solve for it. Just like for a loan, you have all those formulas to calculate the interest and all the formulas to calculate the principal. So you still have all those various formulas to use, and there's not one right way to solve them. Sometimes one is easier than the other.
So I have a quick question on this one.
Sure.
So what's a little confusing to me is we have coupon payments of 50, correct?
Uh-huh.
But then our interest portion is more than that.
Yes.
So is that because we're decreasing the value because we're coming up here, right?
Bond. So yes, it can never happen on a loan.
Okay.
And that's why it is a little hard, because you're trying to think of that. How can that be possible? Like the interest portion be greater than the payment.
Right.
But it's because it's a discount bond. So it's going like this. So the interest of it does exceed the amount of the coupon payment.
Okay.
And
that's
in other words, it would be like if you could have negative principal on a loan, you'd get the same thing.
Right. It's yeah. So it's a discounted loan or bond. So that means that they're essentially like paying us. Well, they're paying us more in interest. Okay, this kind of makes sense. I'm almost there.
Okay. Yeah. Maybe if you drew the picture. The other thing to remember is a loan is always going to 0.
Right.
But for a bond, it's starting at its price and it doesn't go to 0. It goes to the redemption amount.
Right.
So that's another thing that's not really intuitive. So in this case, the price is maybe going from 800 up to 1,000. So as it's going up there, the premium amortization is negative. So the balance is going up by interest, and then a loan, it would be going down by the amount of principal. Now it's going up by the amount of premium amortization. So it's a little harder to try to get an intuitive feel for it. So I know that sometimes I like to have that intuitive feel, and other times I just like the algebra. And so I don't worry about it too much.
All right.
But
thank you.
Yeah, just know that in the back of your mind, if you get something like that on a bond, it doesn't mean that you're wrong.
Okay.
But that
That's
was a good
good.
discussion to have because it does seem weird. And that's the only thing that's not a complete parallel between loans and bonds.
Because our coupon payment is made up of this interest and then also the principal. Like, what's the other portion of the coupon payment?
It's premium amortization.
Okay, so the premium amortization is what's negative.
Yes,
Okay.
the interest
Okay.
portion is negative.
Okay. Cool.
Yeah. You could describe that as saying the accumulation of discount is positive. So, I mean, if you do it the book's way, you can say each coupon payment is part interest, part accumulation of discount, if you wanted to keep everything as a positive number.
Okay. Interesting.
Yeah. And so there might be a benefit as far as an intuitive feel to go down the path of saying, all right, DA is positive, so my coupon payment is a positive plus a positive.
Mm-hmm. Okay, that helps. Thank you.
Uh-huh. Okay, so that, oh, number 5 is kind of something like that, where I go into more of an explanation. So maybe this will help. So on number 5, we have a discount bond. And again, here's what the picture looks like for a discount bond. Here's the redemption amount, and the price is below that. So the picture of the book value is it's going up like that. And obviously, the absolute value of C minus P is the same as absolute value of P minus C. So from that, I mean, to do algebra, like on that other one, we did have to keep track. The way I set it up, it was a negative number. But if all you're working with are these numbers to find out what the interest rate is, you can treat the PAs as always positive if you're trying to find interest. So in this case, the premium amortization would have been negative, but if you're trying to find the interest rate, you would have a negative number over a negative number. You're going to get the exact same formula for the interest rate. So just so it wasn't confusing and I had negatives all over the place, I said for this, you can just treat them all as positive numbers. And remember when we had a loan would start at the amount of the loan and would always go to 0. And if we wanted the total amount of the loan, we could just add up all the principal portion. And if you added up all the principal portion, that would equal the total amount of the loan. So the same thing applies. In this case, we wanted to see what is the total amount of the accumulation of discount over at the beginning of the bond. In other words, what is the difference between C minus P? And again, that's going to be the same as the absolute value of P minus C. So again, I just did it all as the absolute value because the answer has to be positive. It says, what's the total accumulation of discount? Well, it's not going to say it's negative premium amortization. So the answers are all positive. So to find out the total amount, just like if it was a loan, you would add up all the principal portion. Now you would add up all the premium amortization. So in this case, it's a, how many year? It's a, it's got 40 payments. So to calculate the total amount of discount, we would have to add up all 40 of the premium amortizations. But we use that same trick. I wanted to go over this because we showed that it works for loans. because the ratio of each payment is a geometric series, you get this really cool formula to determine the total amount of premium amortization or accumulation of discount at time 0. So we're given the premium amortization in 2 different payments, and by taking the ratio, we can find out what the interest rate is. So we were given the premium amortization in the 15th and the 20th payments. So from that, we have 1 plus I to the 5th is that ratio. So we can solve for yield rate from that. And the yield rate turned out to be 9.5%. Okay. And now here I just derived that formula again, like I did in class for loans. Since we're trying to find out what the sum of all the premium amortization, the premium amortizations at time 2 is the premium amortization at time 1 times 1 plus I. And it just is that geometric series. So premium amortization 3 is PA1 times 1 plus I squared, and so on. And when you add that up, you just get S angle N. So again, whether you're working with loans or bonds, this difference at time 0, you can get by finding, for a bond, the premium amortization in the first year times S angle 40. And if it was a loan, this would be the principal amount in the first year times S angle, whatever the duration of the loan is. So you don't have to derive this each time. Just know that that formula works because it's a geometric series. So if you're ever looking for the difference at time 0, you can just, and that's why we needed the interest rate, so we could use what S angle 40 was at 9.5%. So that's a good one. And whether it's on loans or bonds, it's a great formula to know, that S angle N formula. It's another one that's not very intuitive, that to find the total amount of principal, it has an S angle N in it. You would think there would be an A angle N, but all right. Number 6 was, well, at least it looked like it was an easy one. What were we given on number 6? 2 20-year bonds have par values of 1,000. The annual yield, no, it's 5% compounded semi-annually. Bond 1 has a coupon rate of R and a price of 9.20. Bond 2 has a coupon rate of R plus 2 compounded semi-annually. Calculate the price of bond 2. So yeah, this one was straightforward. Since the yield was 5% semi-annual, I is 2.5%. The price of bond 1, well, just using the Frank formula, 920 is 1,000. Well, the coupon rate was R semi-annual, so R over 2 times A angle 40 at 2.5% plus 1,000 V to the 40th. And from that, since R is the only variable, you can solve for the coupon rate. R is 0.0436. Yes, 0.0436. And now for bond 2, the coupon rate is 2% higher, so R plus 0.02, but it's still semi-annual, so you have to divide it by 2 times the angle 40 plus 1,000 V to the 40th. And so you're just recalculating the present value of the coupons. And so you get the price of bond 2. Of course, it has to be higher than the price of bond 1 because it's paying higher coupons. So that one would be one that finally, there's one that is doable. Number 7, I don't know if anyone tried that one. That might fall in the category of skip. but it's good to go through it because it's got a lot of tricks in it. And maybe in this case, the amount of tricks isn't worth putting all of it together to solve one question, because it would probably take 10 to 15 minutes. But knowing those tricks could probably help in a question that didn't have as many. So it's still good to go through. So for number 7, we have 2 N-year bonds. They're cleverly called Bond A and Bond B. They both have a par value of 1,000. Bond A has 8% semi-annual coupons. Bond B has 11%. And they're both priced to yield I, compounded semi-annually. And they have their prices given. And now it says to recalculate the price of bond A if the yield has dropped by 1%, still compounded semi-annually. And we don't know N and we don't know I. So, but we do at least have some place to start. We have the price of bond A is 40 A angle 2N plus 1,000 B to the 2N, and we're told the price is that 1,100 number. And the price of bond B, it's got coupons of 55 A angle 2N plus 1,000 B to the 2N. And we have 2 equations and a lot of unknowns. We don't know N or I, but a standard trick is if you subtract these 2, at least the 1,000 B to the 2N's cancel. So the price of B minus the price of A, which is just 15 A angle 2N, well, we know what that is. So we know that A angle 2N, if you divide both sides by 15, is 20.29. So hopefully that'll help in some way. A angle 2N is 20.29. And now if we go back to price A, now that we know what A angle 2N is, we can solve for V to the 2N. So here's the 40, now that we know A angle 2N. So plus 1,000 V to the 2N is that 1,100 number. And so V to the 2N is 0.292, 28985. All right, now A angle 2N is 1 minus V to the 2N over J, where J is the semi-annual effective rate. And now that we know V to the 2N and we know A angle 2N, we can just set this equation up. And from that, you can solve for J. So that wasn't too horrible. First, you solve for A angle 2N. And then if you know A angle 2N and you know V to the 2N, you can solve for the interest rate. So from all that, we got the semi-annual effective rate is 3.5%. Well, now we can use that to determine what 2N is, because we have V to the 2N is 0.28985. And so you just take the log of both sides. So 1 over 1.035, now that we know the interest rate to the 2N is 0.28, take the log of both sides, and you get 2N is 36. And now you know the interest rate and you know 2N, and so now you're just solving for the price of bond A, but instead of using 3.5%, we want to use 3%, not 2.5, because it says it's the yield minus 1 compounded semi-annually. So another place to make a mistake would be to subtract 1 from the 3.5%, but you only subtract a half, because if J is 0.035, then I is 0.07, I minus 0.01 is 0.06, So the new J is 3%. And now you just plug it in your financial calculator. The new price is 40 angle 36 at 3% plus 1,000 V to the 36. I just did that as a bond calculation on my financial calculator. So that probably was a lot to do in 5 minutes. It had a lot of moving parts, but it's good if you go through that at your leisure and go through each step, because you'll see patterns that'll come up again. Like if you have two equations and two unknowns, of course your natural thing would be to subtract them and see if something nice happens. And then you just keep working away with your formulas, and hopefully there's a way to isolate each of the variables. For all I know, there might even be a slicker way of doing it. This was, I feel, was kind of a brute force way, but I didn't want to spend too much time on trying to think of a really clever way to do it. If brute force works, that is usually the way to go. Sometimes you do have to think of a clever way, but if you got this far and still had too many unknowns, I would just skip it. But at
I have a
least
question
for that
about,
one. Huh?
I have a weird question about this one.
Sure. Uh-huh.
How much, I mean, obviously it's like we said, it's like a speed and accuracy thing, but like when stuff has like a bunch of algebra, I like enjoy it. Is that something I should like take into account if I'm enjoying doing a problem?
Yes, definitely.
Okay.
Yes, because as long as you don't get crazy about it and do just the ones you enjoy. Because if you enjoy a lot of them, that helps. But no, I get into that mode too. I like ones where there's a lot of algebra involved,
Yeah.
and there's not a lot of numbers, there's a lot of letters going on. So yeah, I get excited by certain types of questions, and I don't know, it's just like chess. If there's certain openings that you like, you study those more, and when you're playing a game, if you get into that opening, you're in a natural groove. So yeah, take advantage of that as much as you can on these
So like
kind of
if I could tell it's gonna take a little bit longer, but I'm gonna like be enjoying doing it, how much should that factor into me choosing
as
to do a
long as it's
problem?
not a lot more, because if you're enjoying it, that probably means that you're going to get it right when you do get to the end, that you're
Okay.
not going to fall for a silly trick like that, subtracting 1% at the very end.
Okay.
But yeah, I would spend more time on those than on one, you know, like it's got a, if it's a part or exam P problem, and it's got a double integral, and one of the limits is a y minus x. I mean, nobody likes those kind of problems, but maybe somebody does and says, oh, I love those. I'm going to spend time on that. But yeah, knowing which ones, even like if two of them are going to take 10 minutes and one is a topic that you feel comfortable with and enjoy, then obviously spend the 10 minutes on that. And the other one, you go, I've seen these, I don't have a natural feel for them. It's going to take 10 minutes anyway, skip.
Okay.
So those are really good test taking techniques that I'm glad you're asking, because I don't always remember to pass those along. But a lot of the exam is psychological and knowing those kind of things. So thanks
Yeah,
for
because
asking.
like if I start getting frustrated, I think it like makes the rest of the test worse as well because I'm
Yes,
like still frustrated about that problem versus
right.
doing something I like. Then my next problem, I'm like, we got this.
Yes, you're getting a better mental attitude. And I was talking to another student who we were talking before anyone else signed on, basically saying the same thing, that you get into a point where you get discouraged if you hit a question. But if you know it's in a category of ones that you just don't like, then it's not that bad. If you have some where you know it's going to take a long time and you enjoy it, then those are good ones to focus on.
Okay, cool. Thank you.
Uh-huh. Thanks for asking. Number 8 was a little more straightforward than number 7. You have an N-year bond with semi-annual coupons. You have the par value and the redemption value. So C equals F is 2,500. The coupon rate is 7% semi-annual. The yield is 8%. And it says the book value immediately after the 4th coupon payment is $8.44, greater than the book value after the 3rd. So that's a way of telling us the premium amortization is $8.44. Although, again, in this case, it's a discount bond. How do we know it's a discount bond? Because the coupon rate is smaller than the yield rate. So that means the PA is going to be negative. It's really accumulation of discount. But again, you can, well, here I left it as negative. So we have the difference, the book value at time 3 minus the book value at time 4. That's what I called PA4 in class. So it's just the opposite of the way the question was worded. So that's negative 844. But the negatives are going to cancel because when you use this formula, PA is FR minus CI, well, this is going to be negative again because FR minus CI is going to be the 8750 minus 100. And so again, you could have just said, I know everything is going to cancel out. So it doesn't matter if these are negatives or positive numbers, as long as you're consistent. And we use the V to the 2n minus t plus 1, because again, it's an n-year bond with semi-annual coupon payment. Excuse me. And so you get a V to the 2n minus 3 is just by dividing 844 by 1250, you get V to the 2n minus 3 is that. And then you take the log of both sides, and you get 2n minus 3 times the log of 1 over 1.04 is the log of what you just calculated. And I got 2n minus 3 is 10, so n is 6.5. So it means there was 13 coupon payments, and it was a 6.5-year bond. So that one was pretty straightforward. I suppose you could have gotten the n and the 2n mixed up, but I thought for sure one of the answers would be 13, but there wasn't. So if you did get the n and the 2n mixed up, you would have gotten 13 instead of 6.5, but luckily 13 wasn't one of the answers.
They were nice for once.
I know. It was one of those that if you did it wrong, you said, oops, I know what I did wrong. Number 9. Number 9 is, oh, I like this one. This is an algebra one. No wonder I liked it. So this one I would have spent 2 years on if it was in the exam. So you have an 8% coupon bond is purchased at a discount of X. The 9% coupon bond is purchased at a premium of Y. And the 10% bond is purchased at a premium of 2X. And calculate Y in terms of X. So I might put this one on in my 415 next semester, because I think it's doable. And so I said, let PX be the price of the 8% coupon, P sub Y be the price of the 9%, P sub Z be the price of the 10%. This is that trick that came up in question number 7. So we have PX, well, the coupon is 40, A angle 20, plus 1,000 V to the 20th. The price PY is 45 A angle 20 plus 1,000 V to the 20th. The price of Z is 50 A angle 20 plus 1,000 V to the 20th. So PY minus PX, so if you subtract that, you get 5 A angle 20. And PZ minus PY is also 5 A angle 20. So we know that the difference in the prices are going to be equal because they both equal the same number, 5 A angle 10. Now we are told that X is the amount of discount. So since the redemption amount is 1,000, X is equal to 1,000 minus the price of bond X. Y is the amount of premium in the second bond, so that's the price minus 1,000. And then the third bond, the amount of premium is 2X, so that's the price of Z minus 1,000. And now if we look at that, if we add X and Y together, then the thousands will cancel and you just get PY minus PX. So X plus Y is 5 times A angle N. And then if you look at this, if you want to get rid of the thousands here, you would subtract. And so you have 2X minus Y is PZ minus PY, which is 5 A angle N. So they're equal to each other. So X plus Y equals 2X minus Y. And you just solve for this and you get Y equals 1/2 X. So now is that, do you like that kind or not? Is it no numbers?
It's
Those
fun
are-
with all like the formulas and you can like find out the different pieces.
Yes.
It's like a puzzle.
It's kind of like that one that you were this close to getting right last semester, where you had an amount doubles after so many years and triples after so many years, and what is N as a function of A, B, and C. And you can do it all kind of algebraically like this instead of taking the log of both sides. But
Right, yeah.
this is a fun one. I might use that next semester. Okay, number 10. That one looked pretty straightforward. We have Smith buys this bond. So the coupons are 25. It's a 10-year bond, so it's got 20 payments. So here's the original bond, and Smith pays piece of 1 for it. But immediately after the 12th coupon payment, he sells the bond to Jones for a price of P sub 2. And the question is, what is P sub 1? What is the price that Smith paid? So first, we'll see what we're told that the yield to maturity for Smith is 7% compounded semi-annually, and Jones is 6%. So if Jones got a 6% return, that's 3% semi-annually. So we can find what he paid. It's just the present value of the remaining coupons. So 25 angle 8 at 3% plus 1,000 V to the 8th. So from that, if he realized a 3% yield, he must have paid $964 for it. And so from that, we can calculate what Smith paid because he realized a 7% yield. So we just calculate the price where the redemption amount is what he got for it when he sold it. So you don't use the original because from his point of view, it matured for $964.90. So from that, you can just solve for what he must have paid to realize the 7%, which of course translates to 0.035, and times the 960 times v to the 12th, and I got 880.14. And again, if you haven't seen one like that before, once you see one, you'll know what to do on those. If someone sells it, that sales price turns into the redemption amount. All right, and then the last two were callable bonds. And so I did both by the shortcut. In question number 11, Sue purchases a 10-year 4% bond with coupons payable for a price of $10.21. It says the bond can be called at its par value of X on any coupon date starting at the end of year 5. The price guarantees that Sue will receive a nominal rate convertible semi-annually of at least 6%. So what is X? So the $1,021.50 is the price of the bond that will guarantee a yield of at least 6%, and it's a callable bond. So step one of the shortcut, is this a discount or a premium bond? So we have to compare R versus I, and the coupon rate is 4% and the yield is 6%. So the coupon rate is smaller than the yield, so it's a discount bond. And so if you get a callable bond question that's a discount bond, you don't even have to worry about the fact that it can get called early. You just calculate it as if it was a non-callable bond. So that price that she paid, $1,021, well, the coupon rate was, what is it? The coupon rate, oh, 4%,
Yeah.
semi-annual. So we have the Frank formula for the price is 0.02 times X times A angle 20 at 3% plus X times V to the 20th. So basically we're just solving Frank for the redemption amount. And we know how to value the annuity and the V to the 20th, and we can solve for X. Could you have just used your financial calculator to do that? Maybe. But I guess you could, right? If you know N, you know the interest rate, you know the price. Oh, you don't know the payment. So I don't think you could use your financial calculator. You just know that the coupon payment is 2% of the face amount, but you don't know the face amount. So yeah, if you don't know the coupon payment, you can't use your financial calculator. You have to just set it up as an annuity and a lump sum. Okay, but at least you know that even though it was a callable bond, you just have to use the price to the original maturity date. And then finally for number 12, Zach is going to purchase a $5,000 par callable bond that will pay semi-annual coupons at a rate of 9%. The bond will redeem at par at the end of 20 years. The bond may be called anytime between the years 9 and 15 with a call price of $5,300. What is the highest price Zach should pay to yield at least a nominal rate of 8%? Okay, so this is a classic callable bond where it says, what's the most you would pay to get a yield of at least 8? So step one of the shortcut, is this a premium bond or is it a discount bond? And we do the same comparison. In this case, the coupon rate was 9. We're trying to get a yield of 8. So 9 is greater than 8. So it's a premium bond. So for a premium bond, we have to calculate the price at the earliest of any call date. And here, since there's only one different redemption amount, the 5,300, we have to calculate the price as if it was called at time after 9 years. So at time 18 on the timeline. So here's the original bond. The coupon rate, so 0.045 times 5,000. Those are the coupon payments. 5,000 would be the maturity at time 40. But if you look at what happens if it gets called at the end of the 9th year, well, here's the coupon payments, and at that time you would receive 5,300. So we don't have to worry about years 10, 11, 12, 13, 14, 15. You just have to do the earliest it could get called. So we just have two calculations. One is the original price, and the other is if it gets called at its early possible call date. So for that one, it's the coupon A angle 18 plus the 5,300 V to the 18th. We get one price for that. And then you calculate it if it was held all the way to maturity. And then the rule says you take the minimum of all those prices. In this case, there's just two. So the minimum is if it gets called early. And so the answer is this smaller call price, which is 54.64, which is C. And so knowing that shortcut helps a lot because A, you know whether you can ignore it if it's a discount bond. And if it's a premium bond, if you didn't know that you only had to worry about year 9, like the way the book tries to describe it, you would calculate what if it gets called at time 9, time 10, time 11, times 12, time 13, time 14, times 15. But you only have to do it at time 9. Now, if there was two call prices, if it said anytime between 9 and 15, it can be called for 5,300, and anytime between 15 and 18, it can be called for 5,200. Then you'd have to do it one more calculation to see what would be the price at time 15 if it got called for 5,200, and then you would still take the smallest of those. So callable bonds are nothing to be afraid of with that shortcut. Alrighty, so that was quite a variety of questions on bonds. I think if you go through those 12, review the answers, I don't think there's any bond questions to worry about. I think that covered just about anything that could be asked on a bond question. So I'll try to always choose 12 that pretty much span the types of questions that can come from that topic. And I think topic 5 is NPV, IRR, the dollar weighted versus time weighted rate of return. So that I always found as a kind of a welcome break before you get into duration and convexity. So I think topic 5 will be a little bit easier than the last couple of topics. Okay, well, I'll pause for any questions. Are there any questions out there? Everything's still going great. I hope so. Oh, Tessa, were you able to enroll for?
Yes, I did. I went ahead
good.
and signed up and it let me.
Good, 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 good. So it worked.
So everybody
And
else,
were you able
come
to?
hang out.
Yes, and so again, try to convince all your friends to sign up for 461.
Ollie, I don't have friends.
Yeah, I was
everyone
able
asked
to
for-
sign up for the classes.
Oh, good. So we'll have a nice reunion. if you haven't signed up, there's still time. You have until whenever the semester starts. I'll just go out and I'll guarantee anyone who takes it will pass. So you have a guarantee, as long as you stay in the class till the final, you'll pass.
You really think
like
so?
Yeah,
Well, I don't know what to say.
well, we'll see.
I guess that's going to boost my self-esteem.
Good. Yeah, I mean, I can't envision if someone has actually stayed through to the end, as long as you're turning in assignments, that you're not going to fail. So I'll treat it kind of like a grad class. Because some of the material used to be in a grad class in the finance department.
Oh, dang. That's
But
awesome.
there's a lot of topics to cover, but it's fun. And I think you'll find that IFM, the exam that this covers, the third exam, is actually might be the easiest of the exams. So wouldn't that be great if you got either P or FM out of the way now, and then whenever the first opportunity after the Math 461, if you passed IFM, just like that, you got a job. So hopefully we'll get people in that category to have 2 exams by Christmas or whenever, early next year. All right, everyone. Well, happy Father's Day if you're a dad. Or if you have a dad, know someone who has a dad. Hopefully one of my kids will at least remember to call me on Sunday. For some reason, I thought last Sunday was Father's Day. I guess because I got all these emails about, you can order these things for Father's Day, and not a peep from my kids. And I was all depressed and cranky, thinking, oh, they don't give a shit about their dad. And then my sister, I said, today's Father's Day, isn't it? She said, no, it's next Sunday. So we'll see. I mean, it's still possible they'll ignore me, but I doubt it. All right,
Well,
everyone.
I hope not.
Have a good weekend.
All right,
Yeah.
you too. Do something fun for yourself.
Yes, we'll do something fun.
There you go.
All right. Bye, everyone.
Bye.